Hi there everyone. Here we're looking at what happens when we're looking at the intersection of a line with a circle and or a hyperbola. And so we'll deal with this example first. We were showing that the line is tangent to the hyperbola. So, if that was our hyperbola, we'd have some line that touches exactly once as a tangent, and we've got to show that. So first of all, we will notice that they're both equal to y, which means we can make them equal to each other. So we can start with 4x plus 8 being equal to negative 4 over x. And so our first step of working here is going to be timesing both sides by x. So that gives us 4x squared plus 8x equals negative 4 over x. Sorry, that should be negative 4, not negative 4 over x. And so we add 4 to both sides and we have 4x squared plus 8x plus 4 equals 0. So we can divide both sides by 4, so we get x squared plus 2x plus 1 equals 0, and then factorize that. So I've got x plus 1, x plus 1. So when we solve this, because we've got the same bracket repeated twice, that means that there's only one answer, y equals 1. And it's asking us for the coordinates of the intersection, so we'll put that value back into our original equation instead of x, which gives us 12. So we have one point of intersection at 1, 12. So given that we only have one solution to this problem, that shows that that line would be a tangent. That's the only way that we can have it touch only once. Okay, so in our next example, it's asking us to find the coordinates of the points of intersection between the line and the circle. Illustrate by drawing a diagram. So we'll find those coordinates first, and then we will illustrate it in our diagram. So once again, we've got y here, and we're going to substitute that into here instead of y. So we've got x squared, and instead of writing plus y squared, I'm going to put in brackets x minus 3 squared equals 5. So expanding our brackets, we get x squared minus 6x plus 9, and then collecting like terms and subtracting 5 from both sides, we get this. And I wouldn't worry about solving that, although this one's actually going to be quite easy if we divide both sides by 2. So we get this one here. So factorizing, we'd have negative 1 and negative 2, so our 2 points of intersection will be x equals 1 and x equals 2, and our y values will be negative 2 and negative 1. So that means that our 2 points of intersection will be 1, negative 2, and 2, negative 1. So let's illustrate this by drawing the circle out. So remembering that that is equal to the radius squared, so just need the square root of 5 before we start plotting the circle. So that's 2.23, so about 2 1/4. So I'll just try and sketch this in, actually, we'll sketch this in as carefully as we can, and with a little bit of help from OneNote, that's almost perfect. We just need to make that a little bit bigger, out that way. There we go, that's about right there. Okay, and we'll sketch in our line, which has y-intercept at 3, negative 3, and is going up by 1 each time. And that's our line there. Okay, and there's our 2 points of intersection, which would look more precise if I could draw my line and circle more precisely, but you get the idea with those. Okay, so really it all harks back to being able to solve quadratics, and if you can do that, you'll be fine. So you've got a fair bit of practice there, but just notice that I've set out some specific numbers for you to work on, and you can work through those 3 exercises. And that's it for our simultaneous equations standard. Thank you.